All right, is it time? It is time. Welcome, everyone. Thanks for coming. We are here for the Documenting Your Code from Docstrings to Automated Builds tutorial. It's like the first day of college. Everybody's in the right room. Don't need to go down the hall. OK. Welcome. If you didn't get the links there, we'll get to them again. So if you haven't got the links yet, no worries. I am Jacob Deppen. You can find me on Twitter if you care to read tweets about my kids and Disney things and other stuff like that. Also data science sometimes. Yeah, we're going to talk about documentation. And thanks to everyone who filled out the survey that I sent around. We got really good participation in that. It was super helpful for me to understand where you're coming from. And I've been able to refactor some things a little bit in the talk, hopefully that will meet folks where they are, and we can hopefully have a successful session together. I want this to be open enough that you can ask questions as we go. I'm happy to be interrupted. If I'm in a flow or something, I'll just tell you to hold on for a second, and that's totally cool. I'm going to now pass out some Post-it notes. This is a thing that I love to do. Has anybody ever taken a carpentries workshop, software carpentry, data carpentry? We do Post-it notes. Everybody needs a green Post-it and a pink Post-it. And you're going to keep them kind of next to you. And these are your way of telling me that you're following along, or that you are lost, or you need help, or something like that. So green is good. Red is, I got some problem. I'm not done yet. And in a big group like this, it's easier for me to see Post-its rather than really walking around and finding out. So yeah, just grab one of each, one off the top, one off the bottom, and please pass them towards the back as we go. We won't need them yet for a while, but get them circulated now. So why does documentation matter? I don't think I need to spend a lot of time on this. You probably wouldn't be here if you didn't think documentation mattered, or you didn't care about writing documentation, building documentation. So hopefully we're kind of past that. But I want to get us kind of all on the same terms. And this is how I think about the values of documentation. First of all, we want to help ourselves, right? You're the one who's going to read your code more than anybody else. So you want to help yourself with documentation to revisit your own code. What was I doing there? Why did I make the choice that I made? Next up from that, your team or your collaborators want to be using your code. And you might not be available to help them use your code. So documentation needs to help them get oriented with your code, read your code. Maybe for code review purposes, you're going to have documentation. And it's going to make the code review smoother when they know why you made certain choices or the way you did things. Above that, we want to help strangers use your code. Right? That's the ultimate, is getting people that you've never met to use your code. Whether that's people at your company in the future, whether it's an open source project that you're distributing to the world, you want to build documentation that other people can use. If it isn't documented, then your code kind of doesn't exist. Right? This is something you've maybe heard said before. If it's not documented, it doesn't exist. And that's pretty much true to some extent. Finally, kind of reaching documentation enlightenment, our documentations will actually do some teaching for us. They'll do some teaching to other people, to strangers, about how to use our code, what our code does, why it does it, what are some interesting ways to use the code. And you never have to interact with those people, right? You think about all the open source projects where you've never interacted with the maintainers, but you've somehow learned to use the code. You've maybe never taken a formal class in some kind of coding technique or whatever, but you've somehow learned it, right? Because the documentation was there for you to learn it. And that's what we're kind of eventually want to try to reach. But who am I? I have a bunch of different things going on for me, but I'm a data scientist. I work for Corteva Agriscience, a big tech ag company. I'm also simultaneously finishing up my PhD in archaeology at the University of Washington. where I did a lot of data science kind of stuff for my PhD project. I maintain a couple of open source libraries. One's called Pandas Vet, which is a linter tool specifically designed to help you out with pandas. Prospect, which is a simulation tool for archaeologists. And I like to do a lot of stuff in the community. The Puget Sound Python community has been something that's been really influential for me, and I've tried to give back a little bit there. And the Carpentries, I mentioned that with the sticky notes, a great organization that teaches groups of folks, mostly people in research fields, how to start coding, how to start using digital tools in various ways to make their work better, more reproducible, and kind of make them better data scientists or better scientists who use digital tools. But who I am not is any of these people who are people who really think deeply about documentation and do documentation as a, if not full-time job, as a big part of what they do. I wanted to put their names up there because a lot of what I know about documentation is drawn from their work. Some of the tools we're going to use today are built by them, and they are kind of the experts of the experts. There's links to everybody's Twitter profiles and stuff like that in that links page, so you can find out more there. But if I'm not an expert, why am I leading a tutorial on documentation? Like a lot of you, I suspect, I like good documentation. I value good documentation. And I also want to get stuff done. And I don't want to have to become one of those people you saw on the previous slide in order to be writing good documentation, building good documentation. I want to be able to find a way to make documentation a little bit easier for me. Find a way to make documentation a little bit quicker. There's all kinds of incentives out there I work in industry. Documentation is not part of my evaluation. It's not how I'm measured in my job. So for a lot of us, it's a secondary thought, but we still want it to be good. So we want it to be as quick and easy as possible to get to that good stage, or get to that stage, whatever it might be, stage that works for you. And so I've gone through this process for a while. I've thought about what works for me. I've tried a lot of different documentation workflows and tools and things like that. And what I'm going to teach to you today, what we're going to kind of build together is a workflow that I think works pretty well for those of us who can't or don't want to become super deep in the documentation world, but we still want good documentation. I want documentation that I can build with and write with tools that I already know. I do a lot with Markdown. A lot of folks do a lot with Markdown. Markdown's kind of everywhere these days. So wouldn't it be great if I could write all my docs in Markdown? I also do a lot of stuff in Jupyter Notebooks. Wouldn't it be great if I could write all my docs in Jupyter Notebooks? I write docstrings for my functions and classes and all that good stuff. I want my docs to use those. I want to just press a button and have it go, find all those, give me some nice, pretty documentation. I don't want to mess around with CI/CD too much. You're going to always have to mess around with CI/CD. If you've ever tried to set anything up on any kind of CI/CD system, there's always 12 commits of you fussing with it and trying to get it to work. A lot of us have been there. But we can make it as minimally fussy as possible, I think, and that's kind of a goal. And I want it to look nice by default, right? We don't want to have to spend a lot of time custom, tweaking CSS, which is something that I know basically nothing about. I want it to look nice right out of the box. I don't want to have to call in a product designer to get some documentation that's going to be nice and readable and modern looking. So what about Sphinx? Sphinx, I know some people, based on the survey, have tried Sphinx or used Sphinx a little bit. Sphinx is, I call it the human-headed lion in the room. Get it? It's a Sphinx. It's a tool that has been around for quite a long time, and it is the de facto standard in Python. But if you've played around with it very much, you know that Sphinx is sort of a time longer ago, and it's not the most modern of tools. It is incredibly powerful, but that also leads to a lot of complexity. And it's often complexity that we're never going to touch in the projects that we need to document. Professional documentation writers use Sphinx, and they use it to great effect to do really amazing things and build really amazing documentation. But for most of the projects that folks in the Python community are going to be working on, we're not going to have that level of documentation, right? You might want to document a little Python package that you've been working on for your team in your company, and it doesn't need to be totally kind of vetted for a broad audience. It needs to be understandable to the people, 10, 12 people in your team maybe. So that's the scale that we're thinking about here. We're not thinking about the most complicated projects in the world. And that's why I think we're going to try to touch on Sphinx. Sphinx is going to be behind everything we do today. So I don't want to make it seem like we're getting rid of Sphinx, because Sphinx is actually there the whole time. It's the backbone of everything we're going to do. But I'd like to touch Sphinx as little as possible because of that complexity. And we want to try to reduce that complexity for us as much as possible. So there's pros to Sphinx. It is the backbone of tools that we're going to use, like Jupyter Book and many other kinds of things that interact with Sphinx. It has a really large ecosystem, and this is part of that complexity. Different kinds of templates. The extensions is what we're going to make use of today. And if you want to host your docs on Read the Docs, you've almost undoubtedly found documentation hosted on Read the Docs if you've done anything in Python. It works really nicely with Sphinx. And so there's a lot of compatibility there that's very natural on both sides of that equation. But Sphinx is complicated. Complex maybe is better than complicated. It relies on things, or can rely on things like makefiles and other technologies that you may not have a lot of experience with, or you may not want to learn as part of documenting your Python package. And it may not be compatible with whatever system you're on, and you have to find a workaround. And that's the kind of complexity that starts to compound and ends up with people just not building the docs, right? Not writing the docs, not maintaining the docs, because it's a pain to update them, and all of those things. And we don't want to be there. We want to keep our docs as kind of light and flexible as possible until you become NumPy and a massive open source project that needs really complicated documentation and really a lot of thought in it. But most of us aren't doing that, right? And Sphinx, in its kind of original form, relies on restructured text. And I don't know of things beyond Sphinx that use restructured text. I'm sure there are some. But they're not common in the daily workflow of somebody who's doing a lot of Python stuff. Things like Markdown, Jupyter Notebooks with Markdown, that's something we're usually a little bit more familiar with. Restructured text is its own world of markup. And if you don't want to learn it, we can mostly skip it. We'll do a little bit of restructured text here in a little while, but just enough, okay? So we're going to do just enough to be useful. In my pre-survey, I asked folks how many people had tried to use Sphinx to build documentation and how many people were successful. And 10 people had tried, and 4 people were successful. And this is kind of a gap that I think it's a leak in the pipeline of documentation, right? That I think a lot of people encounter in the Python ecosystem is you try to do the right thing. You try to build documentation for your project, but Sphinx is a little more complicated than you wanted. And there's other priorities in your work. So it gets kind of pushed back, and something you're going to do later, or something that just never quite happens or never gets updated after you get it built one time. And so I think this is a common story where you try Sphinx, maybe you get something working, maybe you don't, and then maybe your project has documentation and maybe it doesn't. Right? So we're going to start with a little bit of a motivating case for today. This is where I hope that we're going to end up by the end of our session. Okay? We're going to build all this together. Oops. We're going to build a web page. It's going to be live on the internet that looks something like this. It's not the most glamorous, There's the ability to add images here that I haven't done. But It's live. It has, let's check out some features. Well, one, it has a search feature built in. We don't have to do anything special to get a search. We can put a guide here. We have a nice table of contents on the right side. We get some code blocks. We get the auto copy little thing. This is becoming more and more common. You start to see this in documentation, and it's so useful. Just this little guy to copy what's in the box. There'll be syntax highlighting and other things. This is a Jupyter notebook that I have added some special kind of box to make a note. You might add a caution or a tip or something like that, a call out. I can put code. I can mix it with Markdown. This might be something familiar if you've used Jupyter notebooks a lot. But mixing all that together into a sort of guide or more prose style documentation. But we also get some technical documentation, reference documentation that you're probably familiar with. Function signatures, arguments, types, all of that formatted nicely for us. And we can even click on the source and see the raw code that's behind it. All right. And so here we start to have a pretty good foundation for documentation, right? We have the ability to drop a Markdown file in and add a new guide, to add a new module to our package and get it built automatically in the reference documentation with nice syntax highlighting and all of that stuff. There's some other extra features that we'll see along the way. And a lot of this functionality comes from Jupyter Book. And that's the tool we're gonna try today. So that was our goal. The sticky notes I mentioned, green is all good. I'm finished with something that we're working on, or I'm ready to move on. Pink is, I have a question. Some of you in the back, I still might not be able to see your pink sticky notes. So if you do have a question, please go ahead and raise your hand. That's totally cool. But the sticky notes are good when everybody's working on something and I can kind of take a look around. Or help, I'm lost. That can be good as well. So if we haven't gotten the code, we need to fork the repository from GitHub and then clone that to our local machine. Is there anyone who has not been able to do that yet? I have time built in. We can wait. So if you have done that, put a green sticky note up. Yes, thank you. You can just put it on the top of your machine, maybe. That can help me know where we're at. And if you haven't, keep your green sticky note down. Or if you have a question about that, you can put the pink sticky note up or flag me down. Intruders. You should be ending up something like this. If you can open whatever your preferred editor is, just so we have access to this. And what I've done here is created what is effectively, in its current state, on the main branch, is a runnable Python package. Right? Everything should work, I think think it works. But it's not documented at all. There's no documentation in it. So what we're going to do is progressively, over the next couple hours, is add more features of documentation to this existing package. Okay, we're going to take it from 0 docs to what I showed you, hopefully the full thing live on the internet. This is setting up an environment. So if you haven't installed all the dependencies, who has not installed all the dependencies yet? Doesn't have everything going yet. All right. I like to use Conda to manage my environment, so I'm going to activate my environment. And I'm going to do a git status. Cool. I'm on the main branch here. So you all can work on the main branch if you want of your fork. I don't care where you work. But I'm going to switch to a new branch just so that I don't mess up my nicely put together tutorial by accidentally putting something on main. So I am going to just start from a new branch myself. All right. I'm going to move forward. If you haven't finished that, keep working on it, and you'll have time, I think, before we really need to. So I want to take a few minutes, explore the code. So look at that randomly package. There's 4 modules in there. What are they? Facts, palette, points, and password. Take a look through those and see if anything seems familiar to you, anything that you could see yourself writing. They're dummy functions, so cut me some slack. But something that you want to work with, and then we'll work with that module, or you can work with that particular module through the next series of steps that we're going to do. I'm not going to ask you to document every single module and every function in there through the whole workshop. So see if anything seems interesting to you. Get familiar with it, maybe what it does, how it works, as best you can, because we're going to have to write some documentation about it. Flag me down if you need any help with setup or questions. Selected a favorite module to use. All right, I'm just curious. How many people chose the facts module? Okay. How many people chose the palette module? Okay. How many people chose what were the other ones? Points. And how many people chose password? Interesting. Okay. I'm happy I hit a pretty good cross-section. I figured palette would be the least popular, but I'm glad. Great. So let's work on what I call documentation level 1. This is this kind of bare minimum stuff that we want to be there that you can control pretty easily without any building tools, without any extra stuff. Just regular plain old Python can get you documentation level 1. Things like code comments, type annotations, docstrings. Some people don't maybe think of these as documentation, but, well, docstrings I bet you do. But code comments are a very fundamental form of documentation. Okay. Code comments, right? We start with the hash, number sign, and then something there. We can write whatever we want in our Python files. There's no limit, right? Maybe there's some theoretical limit to bytes and things like that. But there's no real limit to what we can write as a code comment. It's the easiest way to add some documentation to your code. Put something right next to the code that you're writing, and you can write whatever you want. Some rules of thumb to try to keep in mind: where to put a code comment. Not everything needs a code comment. Anything that you would consider clever, anything that you think is like, oh, I'm proud of myself for that one, that should get a comment, because what's clever to you is confusing to somebody else, almost certainly, or even confusing to yourself next week. I found that's the case a lot of the time. So if you feel like you're being clever, great, but document why you thought you were so clever, because it might bite you in the future. Things like nested data structures, especially in Python, where we have a lot of types being figured out on the fly and not really obvious all the time. Those can be useful to have comments with them. Things that are poorly named, maybe you're using a package and you think, wow, this function has a terrible name. It's called make square, but I'm actually making a rectangle from it, or something like that. Those things are great to have a comment to say that, like, okay, the function's called make square, but really we're making a rectangle here. Anything with a non-obvious type, that kind of goes to the same point as the nested data structures. And really, the best thing, to describe your reasoning, to describe choices you made. This is stuff that can't really be captured in your code. Why this and not something else? A lot of times when you work in a team of people, there might be some blocker to doing something some way that happens like 3 steps down the line. And so you change things back upstream a little bit, and nobody else knows why it's in some really complicated form. And they look at your code a month later and they say, why did Jacob do it like that? That is so confusing. Why, we could just write it in this one line and it would be done. Well, it turns out the one-line solution has some problem 3 steps down the line, and that's why I wrote it in the complicated way. So those kinds of choices and decisions are really great for code comments, because they really communicate something really quickly, right? Nobody has to go digging. Nobody has to send you a Slack message at your company or find you or reach out on GitHub to figure out why something is like that. They just know because they can read it there in human-readable prose form. Things that don't need comments. Things that are well named already. Your variables that have a really nice name, or your methods or functions that have a really nice name, you don't have to repeat that. If they have a nice verb and action, what they're doing, that's fine, and they probably don't need to be documented that way. And I've seen folks, especially folks who are newer to Python, try to add comments between functions and just kind of all over the place. You can stick that kind of stuff in docstrings, and we'll get to those later. So things like a function signature can be documented in a docstring, doesn't need to be in code comments. here's a couple of examples. They're maybe not the greatest examples in the world, but I think they get the point across. At the top, we have something where we say, OK, we're going to convert to the correct color range for plotting. And that gives us a little bit of the why, right? Why are we converting to the color range? It's so that we can plot it nicely. And that adds something, right? We're adding value maybe to the code there by saying why we're doing it. The one below, and I'm guilty of this as well. When I write code, I often will write a whole bunch of comments that kind of outline what I want to do with the code, and then just kind of fill in the code in between the comments. And then sometimes I end up with something like this. It says read JSON, and the next line is open and read JSON. You don't need to comment that. Nobody should ever get mad at you for adding something like that, because it doesn't hurt, right? It can't hurt anybody. But yeah, that's a place where a code comment wasn't really necessary. But when in doubt, add the comment. So I want you to look at the module that you chose. I think each module only has one function. Is that right? I think that's right. A previous iteration was more complicated, so I simplified it. Try to add some comments there. Figure out what needs a comment, what doesn't need a comment, what kind of information might be useful to convey to someone who's reading this later. Take a few minutes. Take your green stickies down, and you can put them back up when you're done. I wish I had that kind of time. All right. We're starting to get there. All right, I'm going to call it a quorum now. We're gonna push forward. If you didn't get all of the code comments in that you wanted, that's fine. No worries. The next thing we're going to cover here is type annotations. I was really surprised in the pre-survey how many folks are using type annotations already. So maybe this is less of an introduction than I thought I might need to do. But in general, type annotations describe the types of your objects ahead of time. Okay? They're nice because we don't have to guess whether something is supposed to be a list or a dictionary or a tuple or who knows what other type of object it might be. They take a lot of that guesswork out. So in the points module, you have a function like this, generate Poisson points, and it takes two parameters, bounds and rate. But if I need to use that function, what am I supposed to put in those parameters? Type annotations are a really quick way to tell people what is expected in that function. So we have bounds here is a tuple of length 4 with floats in each position. Okay? That's what it expects. And rate expects just a single float. And the last line, maybe hard to see at the bottom for some folks in the back, but we have an arrow pointing to the return type of the function. And in this case, it's going to return to us a NumPy ND array. So, some nice things about type annotations. They make code bases more maintainable. That's kind of what they were originally designed for, and what, kind of the purpose behind them was to help make especially big code bases that a lot of people are working on that might live a long time. They make them a little bit more maintainable, a little bit less cognitive overhead for anybody who's joining onto a project and reading new code they haven't written themselves or haven't seen before. They can make building your docstrings easier, which we'll see, and they're not enforced at runtime. So if you get them wrong, that's okay. You don't want to get them wrong, of course, but sometimes things are just really hard to type. There's a question over here about a matplotlib figure. Those kinds of things are very complicated or tricky to type, and it might just be that it's not worth your time. That's a decision you get to make, whether it's worth your time or not to figure out exactly the right way to type a matplotlib figure in the return type. Okay? Cons, of course, are that the types need to be kept up to date. If you change something, you got to change the types as well. But there's tooling around this that can help. Sometimes you have to import objects just to use them as a type. And there are certain cases where that can be a little bit annoying, a little bit cumbersome, can lead to circular imports in some cases. Again, there's workarounds for that, but these are complexities that we're trying not to add if we can avoid it. And just some things are hard to type. That's kind of the way it goes. The typing ecosystem is booming and growing really quickly. There's a lot of tooling out there around the typing ecosystem. There are tools to enforce the types at runtime or accept types, enforce them in different ways. But for now, we're just going to think of them as documentation, as something that happens kind of statically in our .py files and doesn't do anything at runtime. Okay. So now we're going to add some to our practice module. We have a group of simple types, strings, ints, floats, and bools that are all built in. You get those for free. Other ones you might have to, like collections like tuple, list, dict, you might have to import those. So from typing, import something. In, I think it's Python 3.10, some of those you can just use right away. I think you can use list. Does anybody know for sure? Yeah, I think you can use list and dict and tuple just in the kind of lowercase native form. But for purposes of compatibility here, let's use the from typing import. There's some other special types that you might want to know about. Optional is something that could be none or it could be a value. So we call it optional. I'll show you an example of that in a second. Iterable is sort of a more generic type for something like a list or a tuple that can be iterated over. And maybe your code doesn't care what it is, whether it's a list or a tuple or something. You just need to loop over something or iterate over something. Then you can call it an iterable. And then you can pass in whichever iterable you want. And union as well. Union is a way of saying or, this type or this type. It could be a string or a float, something like that. So let's do some examples together on that. I think if I look at my password, I have a function where there's a default parameter of none. So this is something that's going to require optional. And the way that we specify optional, it's not optional in the sense that it's an optional parameter. It means it's optionally none or optionally something, right? So we're going to, from typing, import optional, capital O. And over here, where we add the type next to invalid chars, or cars, we're going to say optional. We're going to use square brackets. And then I think in this case, we want an int. No, what do I want? Somebody who's looking at that function, remind me. List of something, yeah. Oh, sure. I'm always the guy who's asking people to zoom, so thank you. Is that tolerable? Okay. Yes?
So for large code bases that aren't typed very well, what's your experience, like do you have any experience with using things like monkey type or some of those like auto-typing libraries where code runs through tests and then generates stubs and you can kind of manipulate that way?
I haven't. I've never used those. Yeah, if your code exists already in a large state and then you try to add types, that's a painful experience. Yeah. And that's kind of the situation at Dropbox for which the typing kind of was pushed into Python, where they had a large Python code base that was just so big and hard to maintain, and types made it a lot easier to maintain. So I don't know about any of that tooling that does it automatically, how well it works, or anything like that. Yeah, it's a real problem. If you're going to use type annotations, use them from the start. I mean, obviously you don't always have that choice, but if you can use them from the start, you're going to be in a lot better shape. So here we're going to have an optional, and I think this might even be able to accept an iterable here. It could be a tuple. We're just looping through, right, for invalid char, whatever. And so I think it could be anything that we can iterate over. And again, it doesn't really matter if we're wrong. So here we kind of get them nested. We end up with optional iterable string. Or you can't see it all. Okay. That's one of the more complicated cases. Some of the other ones are a little bit easier. But give it a shot with your demo module. Try to add some types there. Yeah, when you have your types annotated, throw up your sticky note. Don't forget to try to add a return type with the arrow. This maybe is a little confusing because it's broken up over a couple lines, but the arrow to your return type before the colon at the end of the function signature. Yeah, so this is the question they asked earlier. It's tricky. I'm trying to decide how deep we want to go into this. Because in the case of documentation, types for documentation, you kind of do whatever works or whatever you need to. If something is returning fig, then in a lot of cases it's pretty self-evident what the type is going to be. And maybe it's not worth the pain of figuring out those kind of complexities. But in general, you can import the class, the parent class that it is. Matplotlib figures are a little bit weird in that way. And so I put this example in there to generate this kind of conversation, to know that there are edge cases when it comes to typing, and there are things that don't work so well. And so for a lot of tooling around typing, we need type stubs, which are sort of a defined whole other topic for another day. But some libraries don't have type stubs or are still working on it. And like I think if you want to add types to the requests library, you need to import -requests, like a whole separate library. I think that's right. Somebody can correct me. I don't use requests very much. So in the case of matplotlib figure, in that specific case, I will. So we can cheat a little bit, because what you didn't know, maybe, is that built into the repo is all of these levels as different branches of the repo. So if you really screw something up, you can always fast forward a little bit by going to a different branch. So I'm going to move to level 1. And so I imported from matplotlib figure.figure import figure, and then I used that as my return type. These days, especially with popular libraries like matplotlib, there's probably some resource out there that tells you how to type something funky. Anything that's not immediately obvious how you should be typing it. Somebody's had that same problem before. That's a good question. There's always a little bit of a, well, if you're not using any typing related tools on top of this, you can put whatever you want. And Python's not going to care, I think. I think that's right. Is that right? Anyway, you can play around with that. But there's a get out of jail free card if you put it in quotation marks. So if I put that in quotation marks, it's not really going to be evaluated in the same way. And it sort of says, this is the type, but typing tools don't go looking for something because you're not going to have the right information to figure it out. I don't want to go too deep down the rabbit hole of typing because I'm not an expert in docs, but I'm certainly not an expert in typing. And I don't want to give you bad info if I don't have to. Cool? Has everyone got type annotations? Sure. So here, I didn't even tell it what had to be in the iterable, but it's square bracket. Yeah, so you can add this as well. And there's, yeah, go ahead. I'm not sure exactly what you mean. Maybe. So what you could do is you could say, you can define a type like that, right? Everything in Python is an object. You can assign it to an object. And then you can call that invalid type. Is that what you're thinking?
No, for example, the text is the file text, then is there a way to force the user or API coder to use input the language as English and German only?
So you mean enforce the type at runtime?
Yeah, not runtime. Checking time.
Usually what you would do is just do a check at the first line of your code, I think is the natural thing to do there. There are tools like Pydantic that will try to coerce types. So if they put something in and it's not the right type, it'll error out right away, or try to convert it to the correct type. I'm not gonna, again, I'm not a typing expert. That's a good question, but I don't have a good answer. Okay. Let's move to docstrings. I was very pleased in the pre-survey. Lots of people have written docstrings. I know not everybody has, but lots of people have, and that's really good because docstrings are kind of the foundation for all the next bit of cool stuff that we can do in documentation. So PEP 257 defined a lot of the conventions that we need to use for docstrings and best practices. But it's a string that you have at the start of a module, function, class, method, and you can access it later using the dunder doc method, or a special attribute rather. And in PEP 257, they define some good practices like always include at least a one-line docstring for every piece of every class, function, method. Usually you'll want to put more, but at least a one-liner is, let's see, softly required if you want to follow these conventions. And you want to use triple double quotes. I guess it's not exactly triple quotes. Triple double quotes and not single quotes. This is not enforced by Python, but it's just another good practice and kind of standardization of practice there. So the double quotes, triple double quotes like you see up here at the top docstring. And when you're writing your docstring, you try not to repeat the name of the function or the method. That doesn't add any value to you, right? So sometimes it's a really good exercise to try to think of a different way to describe your function that's not just saying the name of the function. I know this is going to be hard to see. I thought I was going to have a bigger screen. But there's three kind of main styles in use. Python will actually let you use all kinds of different styles. Really anything you want, I think. PEP 257 outlines some basics. And these are three styles that follow those basics and then add some other extra stuff to them. The NumPy style is the style that I like. It's a little bit more verbose than, for instance, the Google style. But I don't know, I liked it. I got started doing scientific computing stuff and got used to that style. NumPy and Google are probably the two most common styles that people use these days, and tooling recognizes that. The restructured text style, the kind of native style for using Sphinx, is the one in the top right, and it looks a little bit less familiar, I think, to a lot of folks if you look in raw code. But you might see older code bases that still use that style. It just tends to be a lot more, I don't know, I think a little bit harder to read, a little less human readable than the other formats. But my company uses Google style, so that's the kind that I've started to learn. Yes, question?
Yeah, I was just going to ask, so if I define a function in the docstring, I mean, like I do the triple double quotes and hit enter. It automatically puts the params
Yes.
function in there, but it doesn't restructure text. So is there any other way to update which style?
I don't use PyCharm, but I was looking this up before the tutorial because I'm sure there is. Does anybody else use PyCharm and know that you can change that setting? Yeah. Yeah, I bet you'll be able to find that. In VS Code, there's an extension called auto docstring, I think, that does the same thing. It's really nice. So that's the way to level up your docstring stuff. I intentionally saved those editor tricks for the end of the talk because I want you to try to craft them by hand, but your editor might do it for you. Yes?
The problem might vary from company to company. Generally, we're iterating fast on features, so a function might end up doing more things or its use might change. So how did you usually deal with the problem of updating docstrings? Because we have a lot of developers, some don't update the docstring, and it ends up wasting more time. The docstring is inaccurate, you kind of base assumptions, and then if you have that problem.
Yeah, it's a really tricky problem to solve, right? Sometimes it's a bit of a cultural problem and about setting expectations about what has to happen whenever you open a PR or something. There are some tools that we'll look at later on if we have time that are sort of linters for docstrings. And those can go a little bit of way to make sure things are formatted correctly. There's something called xdoctest or doctest, which is a tool that kind of integrates with PyTest, or you can run it on its own. But you can run your examples. So if you have examples at the bottom of your docstring, I don't have any here, but if you included like examples, it will run those. And so that's one way, and it'll like fail, like a test will fail. So that's one way if you get into the habit of adding an example to every docstring. I mean, it's not going to enforce that your docstring is perfect or that it's up to date, but it's one extra check to say, oh, well, the example doesn't run anymore, so this function must have changed in some meaningful way. Okay. That is a good question and problem to keeping things up to date. Yeah?
I do have one more question. So generally we don't add docstrings to everything. We might have like functions that are self-described enough or simple enough where it doesn't make, I mean, I guess maybe some cases, but do you have like a heuristic you use for stuff? Like we were thinking about like cycle-line complexity, like a function has a lot of potential calls and follies. And some you could look at heuristic there.
I mean, my heuristic is every function should have some kind of docstring. Yeah, that's where it's either the one-liner. If it is, if you're very good at, dry code and breaking things up into nice little tiny functions, then it might only need, maybe your function takes one parameter and it's really well named and does something very small. In that case, you might not need the full parameters, returns setup. But having a line that says what it does is, how much time does it cost? Not very much. And how much time might it save in the future? More than that, right? At least potentially. You have a question?
Yeah, just kind of follow up on that. So something that has been redundant in our code base is that you have type hinting, and then in the docstrings, then you specify kinds of inputs and then kinds of outputs or whatever. I'm just wondering if there's some automatic way of parsing that and kind of auto-generating.
Yes. Wait, you mean in terms of then linting it with that stuff, or?
Yeah.
Oh, that's a good question. I don't know of that tool, but that would be a cool one to build. I think that's possible. So you're saying you have assuming your type hints are always right, you then just compare your type hints to the type annotation in the docstring.
Well, not even, just
Or,
auto-generate.
Auto-generate, yes. And I think that's what he was referring to. I was going to save this for later, a little bit of magic, but we'll do it now. So I am going to install an extension for my VS Code called auto docstring. And you were saying the same functionality, I think, is native to PyCharm. You don't need any extension even. I install it. And now, if I get rid of this, I'm going to go to this other function. If I get rid of this docstring, right, I get a pre-populated generate docstring. And it's defaulting to Google style here. But it'll add in your type annotations. It will find those and add those already. And all you need to add are the descriptions for each of the arguments or the returns. So that's the shortcut. Make your life a little bit easier. You don't have to type out all the colons and all the little bits that are repetitive. Those get built for you. Is that what you were thinking about?
Yeah, dude, that's great.
Good. I should start with the magic next time. All right. So have people been writing docstrings as we've been talking? If you have a docstring for your function, give me a green sticky. Awesome. So that's the end of stage one. You might want to commit your code just to save it. And then we're going to take a break. We're past the hour already, so if tired, break. I have it time is 2:40, so we'll get back here 2:55. We'll kick off. And I can be here to answer questions, talk about stuff. All right, folks. Ready to get back to it? All right. In the meantime, we learned the question that I totally didn't understand because I don't know about TypeScript. There is a way for something. Was it on this function that you were trying to use the literal? Right here with language here? Is this where you were using the literal? Yeah, so there's a type called literal that if we're only going to accept, in this case, if you look at the function, if you haven't looked at it, we're only going to accept English or Deutsch as valid inputs. we can say literal. Is it comma or? Yeah, comma. And that's a way to type annotate it so that we specify exactly which values we might accept. Okay, it's pretty cool. I like that. I learned something. Maybe we all learned something. So thank you. Thanks for asking that question. Right. But I'm going to undo that just because I don't know what kind of havoc that's going to cause later on down the line. Let's move on to level 2. Let's make something that's a little more interesting. We're going to talk about Jupyter Book, and then we are going to dive into Sphinx a little bit and take some pieces from Sphinx that we're going to that are going to be very useful to us. So far, everything we've done is inside our code base, right? It's inside that .py file. We have added the type annotations. We have added our docstring. We have added those code comments in the body of the functions. But if somebody wants to look at that documentation, they have to open your raw code file, right? And that's not a great expectation for when you want to share it out externally. It might be fine for your team, but it's not really fine for other users. So we want pretty docs on the web. That's what we want to aim for, right? That's the standard is pretty docs on the web. You can have images, you can have callouts, you can have links, all kinds of fun stuff, and that's what we're going to try to build towards. So one way of getting there is Jupyter Book. And it's a project for, as they call it, for building beautiful publication quality books and documents. It's not necessarily built as a documentation engine necessarily, but it has a lot of advantages that make it nice for that. First of all, we can use lots of formats side by side. We can write in Markdown. We can write content in Jupyter Notebooks with Markdown and LaTeX and other things. We can write in restructured text if you have existing docs that you want to keep around, or somebody who's engineered some beautiful restructured text thing that you want to not lose. And also MIST is, has anyone heard of MIST? Raise your hand if you've heard of MIST. Markedly structured text is what it stands for. And it's really the glue of all of this approach, where we're gluing together Markdown and restructured text and translating, MIST speaks both. And MIST is mystical to me. It's awesome. It's a cool project that's not very old, and it's really developing, and I think is going to be really productive for us. The config and build system, like any build system, there's a certain level of complexity that we have to tolerate, but I think it's fairly beginner-friendly. Everything happens in YAML files. We don't have make files, which I think is a plus for folks who are doing it for the first time. And it looks great by default. It has a lot of nice modern feel to it, and we don't have to do a lot of tweaking just to make it look presentable. It requires a little extra work to connect it with Read the Docs, but it's definitely possible. Because it's Sphinx under the hood, we can turn it into something that can be put on Read the Docs. I'm not going to do all of that today because, again, that's more complexity, but that's definitely something that you can do and is documented on the Jupyter Book documentation. We can't always use the full range, maybe, of Sphinx functionality. If there's some really specialized Sphinx extension or tool, it may not be compatible with Jupyter Book for some reason. Okay, so that's something to keep in mind, a potential downside. And customizing the look is a little bit trickier. There hasn't been a whole bunch of themes developed for Jupyter Book yet, so it's a little bit trickier to configure for something fancy. There's a really cool example. If you go to the Jupyter Book documentation, I should have put this in the links, but there's a whole gallery of Jupyter books, of example ones that are out there in the universe. There's one called the Data Sitters Club, like the Babysitters Club book series, if you're familiar with that, like the young kid book series, but it's done in the style of the Babysitters Club, like color palette and fonts and everything like that. It's really, really, really awesome. So there are possibilities for configuring it, but it's probably going to require CSS, and I think I said earlier I don't touch it. So let's get moving. Let's create the basics. So inside of our repo, at kind of the same level as the randomly folder, we're going to create a docs folder. Got nothing in it so far. Let's go back here. And here's where we're going to use our links that we opened before, hopefully, maybe. We are going to create a _config.yaml file. So let's just create the file first inside that docs folder, _config.yml. Now I'm going to go to this link. I already have it open. It's in the list of links. It's in here. This line here, JupyterBook config. But what you'll see here is a nice copyable with a little copy button there with all the default configuration that JupyterBook comes with out of the box. And I really like that as a starting point for, I'll just customize that for what I need. But most of the things in that config are things I don't need to touch. So we'll start with that. So I copied that. And I am going to paste it into my config.yaml folder. So let's customize it a little bit. We're going to give it a different title. Call it whatever you want. Author name. YAML is a pretty readable format for doing these kinds of configuration files. That's why it's become pretty popular. There are a few weird edge cases, but in general, I find it pretty user-friendly. So I'm going to say Jacob Deppen. Here, we're going to give it a copyright year. So just so that YAML doesn't think that it's an integer, we're going to put it as a string. I'm going to change that. I just opened a PR on the JupyterBook repo the other day when I noticed that this was still in 2021. Get that changed soon. If you have a logo for your site, you can put a path to it there. We don't have one right now. If there are certain files that are going to be in your docs directory that you want it to skip by default, things like DS Store, if you're on a Mac, you might have that funny little guy laying around. Notebook checkpoints. This is the bane of my existence, the notebook checkpoints always showing up when I try to automate things. But we'll ignore them here. And otherwise, I'm going to leave defaults on all of those. We can give it some configuration of how we want it to execute and build the book. I'm going to keep all the defaults there as well. We don't need to change anything. There are some built-in extensions that we can choose to enable or disable here. Again, we'll leave those. There's some other parameters about getting some nice little tabs at the top, like an edit button, an edit page button. I'm going to change that to true. Same with the other two buttons there. Change to true and true. These are nice because what they're going to do is add a little box at the top of your docs on every page that will allow somebody to like open a PR directly against your docs to help. You know, if somebody finds something out of date in your documentation or a spelling error or some kind of mistake, It can be really nice to they don't have to go find your repo and find the part in the code where this thing is happening and which file it is. They can go directly from the interface in your docs to the place where they want to change something. That's a pretty nifty little feature to use. The rest I'm going to leave. You can build LaTeX. I'm going to leave that. And we're going to come back to these launch buttons and the repository. We'll come back to all of that. And I think we'll come back to the Sphinx extensions. So like I said, JupyterBook is built on Sphinx, and everything eventually gets passed down to Sphinx. So we can leverage a lot of Sphinx extensions, and we'll do that in a little bit. But for now, I'm just going to save this file. And that's a pretty good start for our configuration. I'm going to now create another file, _TOC, stands for table of contents.yml. JupyterBook has some flexibility about how you build your table of contents and how that left nav bar is going to show up and how the hierarchy works and some of that. We're going to, well, I've already made the choice about the structure that we're going to use. We're going to use parts to organize chapters. So again, I can copy this or click my little copy button. I'm going to go back to my code and paste that in. So right now, these are all placeholder pages. We don't have these pages, but that's fine. Let's save this, and we'll come back and edit them when we have some real content to start adding. All right, the last thing I want to add right now is an index page. So within this docs folder, we can add index. And I'm going to, here you can choose your format. I think most folks are going to want to choose Markdown. That's what I like. But if you wanted it to be a Jupyter notebook to be your main page, you could do that, index.ipynb. It could be restructured text. It could be all kinds of different formats that are supported here. But since it's Markdown, I'm going to use Markdown syntax to give it a title. So that's a single hash there. And I'm going to just call it homepage, really original, high quality content. And I'm not even going to add any text. But what I am going to do is add a special feature here. I have triple backticks. If you're familiar with code blocks in a lot of Markdown editors, you'll see the triple backticks. Be familiar with that. And I'm going to open my curly braces there. And there's a special syntax we can use to add a table of contents. All one word. Close the curly braces, and then close our triple backticks. So this is a feature that's going to tell JupyterBook to go into the table of contents from this page, and this is our home page, so it's the top level, and go grab all the pages below it from the table of contents file and put them into this table of contents on this page. So by using this, our table of contents is always updated on the main page. It always stays updated. We don't have to manually add and subtract pages from there. Right? Get some automation. Okay? So it doesn't look like very much here on the screen, just a couple of lines of code. But as we add more pages, we're going to see the full table of contents kind of be realized. Give me a green sticky if you're with me. And a pink sticky if you have a question or need a minute. You have a question, or can I help with something? All right, what else can I help with? A lot of green stickies out there. Cool. Now we're going to add some real content. We're going to add some narrative content. There's all kinds of different documentation content that we can add, but having something that's beyond just the technical, docstring signature kind of documentation can be super useful. Something that is really human readable, something that really explains things. So that's what we're going to build now, a couple of guides. So inside of our docs folder, we're going to create a guides folder. Ooh. Sorry. And the first file I'm going to create inside guides is another markdown file, install.markdown, or install.md. Let's take a couple seconds. You can write whatever you want that tells somebody how to install the randomly package. The title that we give it is going to be the title that shows up in the left nav bar of the Jupyter book. So you generally want to keep it a little bit shorter. It'll just read it directly from this markdown and populate it from there. You can have as much fun with your markdown as you like. I'm also going to add, just for fun, a little tip. So these are those call-out boxes. They're called admonitions in the kind of parlance, where you see caution or warning or note. Tip is one that you can add. You can have your own custom type, but I'm going to add a tip here that'll show up in the call-out box. It's not the most useful or complicated docs, but the actual writing part, thinking about what is going to be a good thing to write in your documentation takes a lot of thought, and I don't have the capacity to put in that thought right now. It takes time to make really, really good docs, right? And
So everything there is just pure markdown. There's nothing there just because we're doing the Jupyter work.
this tip is not pure markdown exactly. Yeah. There's actually a couple of different ways to specify these admonitions. But these are a feature of some of the underlying MIST and the executable books project. And there's a few layers here that add these extra features on top. There's some other features, maybe on the next break. I recommend going to the Jupyter book documentation, or I'll pull it up on the next break, and you can look at some of the extra special kinds of customization you can do to make it look really nice. We're only going to super just scratch the surface here. All right, green stickies. Any pink stickies out there? Wave them. Thank you. I saw one person wave them. I appreciate it. All right, let's move on and build a Jupyter notebook. So I have an install guide. Now we're going to create a guide to the module that you were working with before. Okay, just a how-to. What's it for? What's it going to do? Something like that. So I'm going to use the points module. I'm going to call this points.ipynb. My editor has a Jupyter notebook thing built in. VS Code does. I think PyCharm does as well. Can somebody verify that for me? Okay. Some editors may not. So if you need some help launching that, if you've installed, Jupyter should have been installed with the requirements that we installed. So you should be able to launch Jupyter Notebook, but if you haven't done that before, I can help you make that happen. So when I create this file, it's going to create a Jupyter Notebook interface for me. And for those who haven't used Jupyter Notebooks, you can have a code cell. This one's a Python code cell. You can have markdown code cells. There's other types of code cells, or other types of markdown cells. There's other types of cells that you can have, but we don't have to get into all that here. For our purposes, we're just going to mix Markdown and Python. Now, you could do all of this in a Markdown file by using those 3 backticks and saying Python and then specifying your Python there. The really cool thing is that JupyterBook knows how to run a notebook. So when you build your book, it will actually run the notebook. Or you can tell it not to do that if you don't want to. But we're going to run the notebook so that it will update the content. Maybe you have outputs or graphs or something like that in your documentation. Let's say you have some function that makes a plot, and you document that in your notebook. Then later on, you change that function so that the plot looks a little bit different. But you just need to rebuild your docs, and you'll get the new version of the plot in your documentation. Okay? So that's where this notebook format can be really handy and a little bit more familiar for a lot of folks that are used to seeing those outputs. And you can get a lot of the dynamic outputs that you might get from a Jupyter notebook, like a IPy leaflet map or things like that, so if you know what those are. For our purposes, we're going to keep it pretty simple. We do need to give it we're going to start with a markdown cell and give it a title, because it needs a title. Guide to points.py module. Okay. Yes? Are you using VS Code? You could drag it. You might have to drag it down. You might have to drag the Python one down. You can also do, if you click outside of a cell, like right here, you can hit A, keyboard shortcut to create one above, B to create one below. It's a game changer if you use notebooks a lot. But here I'm going to actually import my module. So from randomly dot points import generate Poisson points, and I can run it. It works. And check that out. Because we've written our docstring and everything, we've added the type annotations. Our editor is now aware of all of that and knows, can parse it and give it to us in our visualization here, right? Another value of writing that stuff. So I'm going to give it some dummy bounds, rate, come on. It's not used to zooming in so much. I think that should be reasonable. Let's assign this to a variable, points. Okay. I can do points.shape. So now I have a little bit of code. This is an example of how the function can run. What I might want to do now is go in between and say, give a more human-readable prose version of what I just did. I might say something like the function accepts arguments for the bounds of a rectangular bounding box and a rate to use in generating Poisson distribution. Okay. What I write doesn't really matter right now. So I want you to try to do that for whichever module you picked out. So the one that you were working with before, try to write a little Jupyter notebook guide. Does anybody need help opening Jupyter? All right, folks. More questions? I'm going to keep moving along. We can fast forward through our Git branches if you're still struggling with this. So we're going to keep moving on this, and then we'll fast forward when you get through this section, and you'll have everything there for you.
Just briefly, just connect the dots between, I guess, what's pulling from what and how. Just
Okay. So in terms of environments and packages?
kind of in terms of now we've created, like he built the notebook, but when he opened the notebook, it showed, basically it opened up a directory of the files he had under the guides. So we know we missed something, and I'm not sure where, but that's what's making me wonder, okay, what is.
Okay, so I'm editing this notebook file inside of VS Code. VS Code has its own kind of engine for doing Jupyter notebooks. It's a convenience thing. You can run and edit Jupyter notebooks from the original Jupyter Lab client. And as long as they get saved back to the same directory in that guides folder, you should be able to, in Jupyter Lab, open up that directory and create a new notebook there. And that's fine as well. Okay? What's going to happen is that when it comes to building our book, we need to have an environment with Jupyter in it. Okay? It's a dependency of Jupyter Book, so if you install Jupyter Book appropriately, you'll have Jupyter. So that's the key bit. Key bit is that in the environment where you build the book, you have that engine, the Jupyter engine, kind of behind the scenes that can run that notebook. Okay. If you didn't get the notebook written, that's fine. We'll fast forward through that part in a little bit. Whereabouts? Oh, that is just my VS Code. I don't have a cell in there. It's just, this is just a pop-up. Oh, so in a Jupyter, yeah, I typed it. In Jupyter Notebooks, you can have a markdown cell, you can have a code cell. So this is a markdown cell. All right. So we have those. Now we're going to add them to our table of contents. I'm going to go back to my table of contents. You remember we didn't edit this before. It's just the one that kind of comes default with Jupyter Book. So I'm going to change my caption here. I'm going to call this section the guides. And chapters are the different pages that go in there. So the path to my first file is going to be guides/install. And I don't put the markdown there. Again, Jupyter Book is quite smart at figuring out what formats it's looking at and can handle many of them. So you actually don't even need to specify the file format for that page. So I'm going to guides install. And here I'm going to say guides, I think I called mine points. Okay. Points is a .ipynb file, but again, we don't need to specify that. It doesn't care. And we can nest them a little further if we wanted to, if you have more stuff, but I'm not going to do that. So I'm going to get rid of that other boilerplate at the bottom. Your table of contents should look something like this. Now is the moment of truth. We are going to go to our terminal, and from our repo directory, we're going to run this command. So I will, oops. Okay, so I'm in my documenting your code folder. I'm going to run Jupyter-book build. I'm going to tell it where to look for the configuration file. That's what it's going to look at first, the configuration in the table of contents files. And that's in the docs folder. Cross your fingers. Boom, something happened. That went really fast because we don't have a lot of content in there. All right, so we can look at this real fast. It tells us where it's finding the config, tells us where it's putting the built files. That we're running Sphinx under the hood. It's kind of wonky on the left side of the screen. It's using Mist to parse this. It's building things into HTML. Reads our sources. It finds a couple of errors. And then it finds something that my points file doesn't have a title. But it did still build something. And at the end of our build, we have a file path. That's the local place where the built HTML is stored. So let's stop there, everybody. If you try that Jupyter book build docs, put a green sticky up once you've done that. And we'll consider it successful if you get to this part with the output. So your build can succeed even if everything inside of it didn't work out perfectly. is if you make changes to, say, one of the pages in your documentation, you have to rebuild it. You do have to rebuild it, but depending on how you configure that, it will cache. Jupyter Book will cache like a run notebook and some of the built files and only run through the things that are newly changed. So you get some speed up there if you have a lot of documents. You're using Jupyter Notebooks. The default action for Jupyter Book is to actually run your notebook, like it's executing it from top to bottom when you build the docs, okay? If you don't want it, there are ways to specify, oh, don't run this particular cell, or sometimes what I do is I want to run my notebook myself, get the outputs that I want to be there, and then freeze it. You can tell it not to run the actual, like not to execute the notebook. That's in the config file. There's something about execute, and you can turn off auto execution. And there's a couple of different options there. But if you turn that off, then it will only just build what's there without actually executing it with Python. If you make changes to what?
Let's make it, you make some change to some other file that's going to modify the content of the book, and then you rerun the build. What's going to happen inside the underscore build? Is it all going to be new every time you run the build?
No, it will cache. By default, it will cache things that haven't changed. If it'll only rebuild the new files. You can mess with that behavior, the caching behavior as well. When it's executing your notebook, it's running the version of Jupyter that you have in your environment. So whatever if you hopefully you're using a virtual environment or content environment or something, then it's going to use that Jupyter, whatever is live. That's a good question.
In my case, I had to run a Docker container with the Jupyter server because I'm having WSL issues, but I would like to point it to that Docker container running locally.
That's a good question. You could, I mean, you could mount the files into your container and run it from like interactively in the container. And then right. And if the if the volume is mounted, then you'll get the files back out outside the container. Yep.
So for closed source projects you're documenting for work, where are you putting your books?
Where am I putting what?
Your teacher books.
Great question. So we're going to get there in a few minutes. So I'm going to come back to your question. That's a good question. The question was, if you're not running an open source project, where do you host your built Jupyter book stuff? That can be somewhat of a complicated system, but we'll talk about that. I want to get through one more thing before we go to break. So again, after this section, we can fast forward. If you've had trouble building, we can fast forward to your repo. But we want to dip our toes into the Sphinx extension universe. Okay. The three that we're going to use, they're very, very common ones you'll see: the AutoDoc extension, the Napoleon extension, and the ViewCode extension. So AutoDoc is going to take those docstrings we wrote and turn them into that nicely formatted parameters and all that nice API reference documentation that you're probably used to seeing. Napoleon is going to read NumPy, or actually it'll read NumPy or Google style docstrings. This is now, I think Napoleon is now built into Sphinx. It used to be that you had to install it separately, but I think it's built in now because so many folks are using it. Before that, you had to either install Napoleon or use that restructured text style we saw before. And ViewCode was that feature I showed at the beginning where when we see the API reference for a function signature, you can click source and view the raw code. Okay? I like that feature. Some people may not want that in theirs, but you don't want to see people to see how messy your code is under the hood. But I think it's useful. So we're going to use those three. First, we need to add an AutoDoc template. And I'm going to create an API folder under docs. So docs, API. I'm going to close some other things. And now you're going to pick your demo module, whichever one you were using, facts or palette or points or password. And we're going to create that module name .rst file. So I'm going to create under API. So I'm going to create points.rst. So we are going to use restructured text after all, after I said how tricky it can be to work with. So now I have a restructured text file. And I want you to copy this syntax here that's on the bottom right. I'm going to read it out in case that might help people seeing it in the back. This is restructured text, kind of pure restructured text. So a top-level title is specified with your title and then equal signs below it. Okay, so in this case, our title is going to be the name of our module, randomly.facts or randomly.points. No file extension there, yeah. It's actually just going to be a string that you could name it a whole bunch of things. This is arbitrary. You can name it whatever you want. This is. So I'm going to say. And then below it, any number of equal signs. I think Maybe you need 3 or something like that. I'm going to skip a line. And here's some classic restructured text. We're going to do dot dot space, auto module, colon, colon, space, the name of your module, randomly dot whatever. This is not arbitrary. You need to give it the real name of the module in your package. Okay. Now at the same level of indent as auto module, we're going to do this members, undock members, and show inheritance. I think I got that right. Yeah. So it should look something like that. Now, if you wanted to document all 4 modules, you could create this exact same file, just swapping out that last points thing, and you'll get the same results. You'll be able to get the same thing for every module. Any pink stickies? All right. So we've added this. It's really boilerplate because you can change out some of these things. You can look in the documentation for AutoDoc to see what each of those is actually doing. In our case, we don't need to worry about that, but there are options to include private functions or exclude private functions, and you can do, Sphinx is so powerful. You can do so much with it, but we're not going to touch that complexity. Now we need to add something to our configuration to tell it to use those extensions. So I'm going to go back to my configuration file. Under Sphinx, extra extensions. I'm going to open a new line here. Sphinx.ext.autodoc and Sphinx.ext.napoleon and Sphinx.ext.viewcode. Those were the 3 that we wanted. And make sure you save your config file. And make sure you saved that .rst file too. So now I have a list here in my YAML file of each of these extensions. Green stickies? Any pink stickies? Okay. I'm going to leave that up. I'm going to open my table of contents so that we can keep moving. And this time I'm going to add a new section, a new caption. I'm going to call it API reference. And my chapters. This is a really killer feature. I can glob for files here. So I can glob for API star. So now it will grab anything in that API folder that we have. So I never have to change my table of contents when I add a new module to my code. I just need to add that RST file to the API folder, and JupyterBook will snatch it up when it builds. So glob, if you're not familiar, is kind of a Linux thing to search or find, I don't know how to describe it, find files with patterns, find things with patterns.
I think they're called wildcards.
Yeah, in this case, we're using a wildcard, but there's all kinds of complicated glob syntax you can use. Okay. How are we doing? Does everybody have that? Show me a pink sticky if you're still working on something. All right. Oh, we did that? Let's build it again. So if you were able to build it before, hopefully you will be able to build it again. Make sure everything's saved. But we build our docs. I fixed my errors, so I don't get any errors anymore. I'm going to highlight that code path. Now we'll see a couple of things happen. We have our table of contents is being auto-generated because we added that little thing on the home page. So it's being updated. We have over here our API reference has this section points. And we have our nicely built documentation from our docstring. That's the end of level 2. So you're welcome to keep moving on that. But otherwise, let's take a break. I think let's take a 10-minute break. If we can be back here at 4:15. I got 4:05 right now, so let's be back here at 4:15. And I can help you finish up if you, or if you want to fast forward, I can help you with that as well. All right, folks. It is time. I want to keep moving so that we can try to get through the big things and have something built by the end of the hour. So now we're on to level 3. If you want to fast forward your code and everything, you can check out to level 2, the level 2 branch. Close all these. I'm sure there's some kind of conflicts or something like that. I'm just going to ignore them. All right. Now I have fast forwarded to my level 2, and I have some API docs for all of the different modules here. You can do that if you like. But in any case, we're going to work with GitHub Actions and GitHub Pages. These are not the only way to host your book. Your book, when it builds, it spits out HTML. So anything that can render HTML and host HTML is somewhere you can put your book. You can put it in, you can configure an S3, an AWS S3 bucket to be a website and you can just send your built docs up there to AWS S3, and you get a super long, complicated URL. But that's great, especially for internal projects. If you want to put something in there, you can manage security through your AWS stuff. When it comes to private projects and GitHub pages, there are now, I think a couple of years ago, GitHub allowed pages to be available for private repos, maybe only on enterprise GitHub. So if you're, anybody work for GitHub? That's something to confirm, but if you are on an enterprise GitHub, you can definitely, I've done this, you can create a private page that works just like the rest of GitHub pages, and so this workflow would work for that. What we're going to do today is going to make it public to the world, but there are ways to make it private, and you can ultimately send these built docs wherever you want. So, GitHub Actions. GitHub Actions are a CI/CD kind of tool to automate things. You can do a lot with GitHub Actions. I saw in the pre-survey quite a few folks have worked with GitHub Actions at some level. You might run your tests, you might run linting, you might do your builds, your deployments of code, all from GitHub Actions. If you use GitLab CI/CD is a very similar kind of process. Jenkins, I think Travis. There's a whole bunch of tools like that out there that do similar kinds of things. But GitHub Actions is nice because if you use GitHub, it's already there for you, and it lives right where your code lives, and that makes a difference. So we're going to specify things in YAML files, just like we've been doing with our configuration before. We're going to write YAML files. And these days, actions have been around for, 4 years maybe? 5 years? And everything that you want to do has probably been done before. You're not the first person to try to do it, and that's really awesome. So there's a lot of pre-built actions out there that you can just use off the shelf without having to write the details yourself. There's a whole world of GitHub Actions that we're not going to get into. We're going to do a pretty simple flow to build our docs and put it in GitHub pages. You can do things like protect your branches until certain things pass through your GitHub Actions as well. So what I like to do is you can't merge your branch until the docs have built. Or immediately upon merging your branch, you build the docs and deploy them. So let's add some actions. We're just going to add one, and it's this long thing on the right. But there's a template for that. We're going to create this directory structure first. This is where GitHub is going to look for your actions. So we're going to create at the top level of our repository, we're going to create a .github. You need the .github. Under that, I'm going to create a workflows folder. Don't need a dot there. And then inside the workflows, you're going to create a YAML file. You can name it whatever you want, but I'm going to call it deploy.yaml. Jupyter Book is well documented and has a template that we can use for deploying a book. So I'm going to go to that link. It should be in the link list. And copy the template and put it here in my YAML file. Let's look through some things that it's doing. We give it a name for this action. And then we have triggers. So we want to trigger it when something happens on, in this case, on push. So when we push to the master or main branch. You probably will have a main branch, not a master branch. So you might want to change this to main. On push to main, that's when this action is going to run. So that's the trigger. For other complicated, or for other GitHub actions that are not related to this docs, you might want to trigger it on something else. But push to main is where we're going to work. Let's go down here. We're going to do, this is a very generic pre-built action for us that we're just going to make use of. And that's check out an Ubuntu operating system. We're going to install Python 3.8. Again, this is a pre-canned action for us. We don't have to write out all the steps to get that there. We just say, use this action and then give it some configuration. We're going to install our dependencies. And then we're going to change our build directory. We're not going to build from the top level. We're going to use the command that we used before, which was build docs. So that's important on line 35 to change that. The next thing is the real magic for taking that built documentation and putting it onto GitHub pages. And this is somebody who has already built this action and written it out. So what we do is it's going to look for a GitHub pages branch. Well, it's going to take the built documentation, send it to the GitHub pages branch. And that's a branch where GitHub Pages is going to look to build itself, to build the site. Okay? Here we need to specify docs again in the last line, line 42. And there's one last step that we need to add to our workflow here. We need to install randomly so that we can run things in our Jupyter notebooks so that the Jupyter notebook can build properly. It will need to know where randomly is. And randomly is not in our requirements file. So it hasn't been installed on in this Ubuntu environment when it's running in GitHub Actions. So to do that, we're going to mimic, we're going to mimic the install dependencies command here. I'm going to call it install randomly. And then we're going to run, colon. The vertical bar is just a way of saying, like, continue on the next line. It's a little bit nicer formatting. And then I'm going to pip install period. Okay, so we're going to install from the current directory at this point, which is the top level of the repository. You could do the -e install if you wanted to, but it's not really helpful because our module is not going to change once it's going through this workflow, so the editable mode doesn't help us. All right, show me green stickies if you're there. Make sure to save your deploy file. Show me pink stickies if it's something you still need a little bit of help with. Any other pink stickies out there? All right. let's see what we can do. We're going to commit this and push it back to the GitHub repository. Now, after you do that push, you should go to your repository. And yours should look something like this. You should have your GitHub workflows here, your YAML file. Everybody there? Show me any pink stickies. All right. Now we need to enable GitHub pages. Yeah. In this case, you can merge it into main. That's fine. You might have a different, little bit more cautious workflow on your own repositories. But in this case, we're going to just merge it to main. So once you're in your repository, we can go to Settings, the top right. And on the left side, Pages. And we're going to tell it to build from the GH Pages branch. You didn't create that branch, but the GitHub action will create it for you. So that is a nice thing, because then the built version of your docs, all the HTML files and all of that, doesn't end up in your main code branch, kind of polluting that branch a little bit. It stays in its own isolated built branch. And we can specify the root of that branch as the GitHub pages. And if you say that again? Change it to docs? Interesting. Let's see how others did. So if you save that, this should turn something. This green box should change color, or it'll say your site is ready to be published, or something like that, maybe. Pink sticky. I want everyone to go to the Actions tab and see what happened. See if it failed. Raise your hand if you got a successful build. Okay, there were some successful builds out there. If it's successful, you should have a green link here, a green box around the link, and your link should open to your built documentation on the web. Pretty nifty, right? But obviously not everybody got there. So let's see what we can do. Pink stickies. Flag me down. Interesting. Yeah, it's writing to that new branch, to that GitHub Pages branch. All right, folks. We have 15 minutes left, so I want to make sure we cover everything. We have covered all the steps to building something on the web. Oh yeah, I had a slide for that. So the last thing I want to add on top of all the things we've built so far is extras. So one feature that we get with Jupyter Book is when we have notebooks, we can turn them into something that is runnable on the internet pretty easily. How many people have used Binder or My Binder before with a notebook? Okay. Binder's really cool. I'm not going to go into the details of it, but really you can configure it in your config.yaml file. And I'm going to use the version that I have already configured. So in the points module, if I come up to this rocket ship, I've configured it to look in Binder. It was just a couple of those parameters in our config file. I can show you which ones in particular if you're curious. But what it's going to do is launch Binder, which is going to Dockerize our repo. There's a tool called repo2docker that is really cool that Dockerizes our repo and then installs some, if it finds like a requirements file and it finds a setup file, it will kind of install stuff. And that's what it's doing right now. And then ultimately, it's going to launch a Jupyter Notebook, live Jupyter Notebook version of the static Jupyter Notebook that we had in our docs. So this is a cool way if you want to have a tutorial that people can also interact with, can change some parameters on, sometimes you might have widgets in there that you want them to mess around with. There's a lot of cool things you can do with this. And ultimately, it's Kubernetes and Docker and everything under the hood. Wait for it. It's going to launch. Almost there. If you did it again, like subsequent times, it will do it much faster. Because the Docker container will have already, or the Docker image will have already been built. Yeah.
I was just thinking while we're waiting, with private repositories and pages, is that, you have to have rights to view the repository in order to view the pages, so is the authentication kind of handled through GitHub already?
Yeah, that's kind of the magical thing that GitHub figured out is just running all the auth to get to the page through the GitHub auth. I have no idea how any of that works, but it does work because I've done it before from private repos where you can build a page. But I think you do have to have enterprise GitHub or some non-free tier GitHub to do that. Any other questions while this launches? All right. We'll come back to it when it's done doing its thing. There's a library called, I'm going to kind of run through these tools. These are not tools that I use a lot, but they're tools that are pretty nifty if you want to level up your documentation setup and your workflows, especially with teams. How many people have used the coverage tool for testing their Python code? What it does is it goes through your code and goes through your tests and says, okay, well, this part of your code has been touched by a test, and so ultimately you get a report on how much of your code is covered by tests. Imperfect measure, of course, but it's a nice thing to have. This is doing the same thing for docstrings. So what we're looking at here is a report that I ran on the randomly module or randomly package that tells us how much coverage we got. So you notice we missed one something in every single one of our modules. That's because according to PEP 257, you should have a docstring at the top of the module that describes the module. We didn't do that. I don't know how common of a practice it is or not. I tend not to use it, but now that I know that it's a PEP 257 thing, maybe I will start using it a little bit more. But that's why we got misses here. This one's called interrogate. The next one is PyDocstyle, which is similar. How many people have used Flake8, the linter Flake8 to run on their code? What this does is it will look through your docstrings, and it will check for some of those best practices things. We'll see what it flagged here. So it flagged missing docstring in a public module. That means I didn't have that line at the top, so that one's going to appear every time. The first line of your docstring should end with a period. That's part of PEP 257 recommendations. I failed at that a couple of times. What else? I was missing one here. Maybe that's it. Oh, after your docstring, you're not supposed to have blank lines. I didn't know that was an official recommendation. But if you want to start kind of enforcing that good patterns of documentation, adding a tool like this to your testing or linting, things that you might be doing already in your code, these could be part of GitHub Actions. Any of these could be incorporated there. You could you could block merging a PR until all of these pass if you really want to. It's up to you how strict you want to be with it. But at least it gives you some insight. And especially as your project grows, you start getting contributions from multiple people. These kinds of tools might give you some insight as to where you're lacking in docstrings or where docstring coverage is weak or needs to be improved. I mentioned xdoctest before. There's an older tool called doctest. But I think xdoctest is really nice. It integrates with PyTest. And here's how. So let's say we have a Fibonacci function. We create a Fibonacci series up to whatever number we give it. And as part of our docstring, we can add an example. We didn't do that in any of our docstrings, but that's how you can do it. You can add an example, and you have the three arrows there, chevrons. The three chevrons, and then you have something that you would execute in Python. So in this case, we're calling the function and giving it a parameter. And then on the next line after that, we have the expected output. All right, so you can think of this as like a test, a software test, a unit test, where we say, given this, I expect this. And what xdoctest can do is actually turn that into executable Python, not just a string as part of the docstring. It will turn that into executable Python and run it. And if it doesn't get this output, it'll fail. Okay. That's pretty fun, I think. It's pretty cool. That's one way to kind of do some regression testing on your docs. If you try to keep your examples up to date, that's an interesting feature. We already talked about editor support for VS Code, PyCharm, how you can use these tools to generate your docs for you, or to at least generate the stubs of your documentation for you and make sure things are as easy and smooth as possible when you're trying to write docstrings. And with that, I am done with everything that I have prepared. I'm happy to take questions, thoughts. You want some feedback on anything like that, I'm here. Thank you. I should add, I would really love if you go out and build some documentation to like send me a message or share the GitHub repository with me. I would love to see it. I'd love to see what's happening and see all the cool things that you can build. All right, thanks.